tracking of discrete unmodeled reference signals in robotic manipulators using output regulation theory and high-gain observers. In the field of control, regulation theory ensures the tracking of reference signals generated by a known dynamic exogenous system, referred to as the exosystem. However, there are applications where the exosystem may be unknown. In this context, the present paper proposes a controller based on output regulation theory, where a high-gain observer is used to estimate the states of the unmodeled reference signals. This observer is structurally integrated into the discrete form of Francis's regulation equations as the exosystem. The proposed approach assumes that discrete unmodeled reference signals are obtained by transforming a given trajectory from the workspace into joint space of a robotic manipulator. As first case of study is considered a reference signal in Cartesian coordinates given by a Lorentz attractor. Lorentz attractor is characterized by its chaotic dynamics, sensitivity to initial conditions, and unpredictable behavior, making it ideal to demonstrate the robustness of proposed control approach. Simulations depict the estimation and tracking of the reference signal for joint 1 and joint 2 with a bounded error. A classical task of a robot is the tracking of trajectories in workspace. As second case is proposed a trajectory in the robot workspace with 5 linear segments. Simulations shown that the exosystem state variables accurately estimate the reference signals. Subsequently, the plant states track exosystem state variables, maintaining bounded errors. In accordance with the Francis's theory, is satisfied the regulation condition in the robot's workspace. A potential application of the proposed controller is the tracking of reference signals generated in real time during human-robot interaction, where free-form trajectories can draw by a user. In addition to the absence of a reference signal model, the presence of abrupt curvature changes and high-frequency components poses a challenge for the regulation task. Then, in this case, reference trajectory is generated using an input device as a pen tablet. The results for state estimation, trajectory tracking in joint space presented a bounded error as previous study cases, satisfying the regulation condition of Francis's theory. The tracking of unmodeled signals using Francis's linear regulation theory in robotic manipulators can be achieved from the assumption that the reference signal lies within the robot's workspace, and by performing the corresponding coordinate transformation, the reference in the joint space does not have a defined model. Since the trajectory is obtained from a sequence of discrete points, the conditions required to solve the regulation problem are established through the modified discrete Francis equations, due to the integration of the high-gain observer. Despite that the controller is designed under the assumption of the linear model, it was observed that the tracking error in each joint remains bounded, which is also reflected in the workspace. The high-gain observer as an exosystem represents an alternative for tracking discrete unmodeled signals, opening the possibility of extending this technique to various areas of robotics, such as computer vision, haptic interfaces, mobile robotics, and different real-time applications.